Welcome to today's webinar, The Power of AI. Today, Parasoft and Applitools have teamed up to show you how we can improve Selenium web UI tests with automated testing and visual AI. I think it's going to be a really exciting webinar, but before we get into the action, let's do a little bit of housekeeping. So today we are doing a Zoom webinar, and what that means is that it's going to be lecture style with running about 45 minutes, leaving 15 minutes for Q&A. If you do have any questions, go ahead and toss those into the Q&A box, and feel free to engage in a little discussion in the chat box with your peers. Let's go ahead and move on to today's presenters. Today, I'm happy to be joined by Daniel Levy, the Senior Director of Global Product Marketing at Applitools, who's going to talk us through the landscape of test automation and help us understand some of the pitfalls and how to take advantage of those with automation. And then Aaron Barliv is then going to show us some really cool technology and how these products come together to leverage the power of AI. And then I am going to, my name is Chris Colosimo, I'm the product manager at Parasoft. I'm going to show you how we can reduce maintenance for Selenium test cases using AI. So with that, I think it's a pretty good agenda. I'm going to go ahead and hand it over to Daniel to go ahead and get us started. Daniel.
Perfect. Thank you, Chris. It is a pleasure to be here with the Parasoft team. You guys have been a blast to work with on preparing this. So here we go. I'll start off with something that may or may not catch you by surprise, but today's approach to automated testing is broken. And you're probably wondering, why is it broken? Well, we keep hearing the same things across various industries that we work with here at Applitools, from finance to pharma to technology and more. Test code is complicated. It's time consuming to write in a way that ensures quality. A recent study we did shows that on average, it took over an hour to write a test, but it took 2 hours to write a thorough test, right? It could take 6 to 8 months to write a test suite of 500 tests, and that doesn't even factor in maintenance. Locators are how automation frameworks find elements in the browser and interact with and validate when a UI changes. And locators often break. You all know this if you're automated testers and test engineers on the call. Locators often break, causing a test to fail. And since the UI is always changing, tests are always breaking. And this takes time for test engineers to fix and rerun, and this is known as test maintenance. And it can consume a massive amount of time. As your test suite grows, more tests are added. So you have now more screens, more tests, using more locators, and this only amplifies the overall flakiness of the test suite. And when you need to run across various browsers and viewports, it introduces that flakiness with probably a 20 to 30 time multiplier, right? Because now you're running these tests that are flaky across, say, 20 to 30 different combinations of browsers and viewports and OSs. And you're now factoring in this additional level of flakiness with a lot of the cloud testing platforms that are out there because you need to maintain a constant connection, right? So you've got the flakiness of the locators, you've got the flakiness of the connection, you've got the flakiness of these VMs that are getting spun up. And this is a hassle, and it wreaks havoc on your CI and CD environment, right? So the net result of this is slow builds, broken builds, and really aggravated developers. All the while, bugs are still escaping into production, right? And I'm certain that the automation engineers that are on the call today, that this resonates with them, because we hear it over and over and over. And when bugs are escaping, they're bugs that can escape a traditional functional test, like what you see here, right? It happens to United Airlines. You go to book a flight and your button's kind of dragged off the screen, right? A traditional assertion is going to go in and say, find this button. Does this button exist? Well, yeah, the button exists, but it's pushed off my screen. I can't see it. So I'm confused. I don't know what to do. And I'm probably not, even if I know what to do, I'm not feeling great about the site, right? And it happens to trying to get your prescription refilled, right? Where are my fields? What's going on? How do I enter my mobile number? Where is it, right? Uh, all this leads to negative ROI, right? Organizations are wasting time and money creating, triaging, and maintaining tests that fail to deliver on the promise of fast releases and better quality, right? Enter Tools. Here we are, the next generation of test automation through visual AI. So we invented visual AI. This replicates the human eye and brain. It's the only visual testing solution that has AI enabled in it, and that unlocks so much potential. It unlocks the ability to speed up your test creation, to have much less brittle code, to run your visual test cross-browser using our ultra-fast grid, and so on and so forth. So how do we do it, right? This is the Tools platform, and adding Tools Visual AI to your existing test automation framework, especially like what you'll see here with today with Parasoft Selenium, allows quality teams to release perfect apps faster and at a reduced cost. At the heart of our platform is visual AI. This is, again, the industry's only AI-powered visual computer vision that replicates the human eye and brain. This allows for the ultimate efficiency, creating tests faster with fewer locators. So now with visual AI, you don't need 10 or 15 assertions in your test. You can reduce that to a single open-ended visual assertion, and that reduces the number of locators in your test. Now, naturally, you still need locators to drive the browser, right? But when you combine that with the power of Parasoft that you'll see, Parasoft self-healing in Selenium, that will help that tremendously. So you're essentially stamping out all brittle locators when you combine these two solutions. From an SDK perspective, we have native integration with Parasoft Selenium, but also we do have SDKs that support all modern test frameworks. And this can be incorporated into your CI and CD environment. And combined with our ultra-fast grid, this is a new product that we have that is changing the game when it comes to cross-browser testing. There's no one else out there doing cross-browser testing like we are, and I'll show you about it on the next slide. So let me just jump over to the next slide. I'm excited to tell you about the ultra-fast grid. This product is really innovative, right? We have a much different philosophy here at Tools when it comes to cross-browser testing than a lot of the cloud providers out there. Our approach to cross-browser testing is modern browsers are working with JavaScript all in a very similar manner. So whether it's Firefox or Chrome or Safari, if you have a bug that breaks in one of those browsers, it's very likely broken in all of those browsers. And if it works in one of those browsers, it very likely works in all of those browsers. However, rendering is a bit more subjective, and these browsers do render different. So visual testing across these browsers is critical. So we're not saying you don't run your functional test. You have to, right? So with Tools Ultra-Fast Grid, you run your functional tests locally. Our SDKs capture the object model of the website, sends it up to our ultra-fast grid. We spin up containers and instantly render that object model across every browser and device that you need, and then send it over to Tools Eyes for visual analysis. And this all happens in seconds versus minutes. It's so fast, and it's incredible. It's a breath of fresh air compared to traditional cross-browser testing. Again, it's a much different approach. And if you're using if you still have a requirement for legacy browsers, then you probably want to have a combination. So if you need to support like an older version of Internet Explorer or something like that, you do want to run your functional tests on that, because that has not gotten to the same point as some of the more modern web browsers that all are rendering JavaScript or executing JavaScript the same. So there are some caveats, but the folks at Tools and Parasoft can definitely get you off in the right direction there. And I think I've got one or two more slides, but just a bit more. We had a report that we put out earlier in the year on visual AI. This is the empirical evidence. And it proved through somewhere around, I think, 1.5 years worth of data that we compiled from this, where hundreds, I think 188 test engineers provided data, and they each spent somewhere in the ballpark of 11 hours. And we showed that creating tests with visual AI was 5.8 times faster than without. and your test code was 5.9 times more efficient, 3.8 times more stable, and we actually caught 45% more bugs. So it's really compelling technology. So with that, I'm going to hand it back over to Chris to talk about how we can further reduce maintenance.
Thanks, Daniel. Really exciting stuff. And yeah, the proof is out there when it comes to executing your tests inside of the ApplyTools platform. I, for one, have been really excited working with your team to see the different capabilities that we have when we get our tests up there that really help us identify where that root cause issue is. And I do honestly agree, ultra-fast grid is a game changer. But one of the challenges that we face is we need to get these tests, we need to build the test automation, we need to create it in a maintainable way so that we can run it in exciting platforms like ApplyTools. And so that's what I'm going to talk us through is when it comes to the test, how do we build it? How do we reduce the maintenance? And so let's talk about frameworks. So Daniel talked about quite a few testing frameworks, and we're really data-driven here at Parasoft. So we recently ran a survey and asked a lot of folks, hey, when it comes to these different frameworks, what are you using to drive your test automation? And unsurprisingly, Selenium has become the de facto standard. Not only is it powerful with an incredible mixture of different libraries for different platforms, it is immensely community supported. I see a lot when I'm working with different clients where their challenges that they're facing with their Selenium testing, they could usually get an answer on Stack Overflow or Google Forms in a matter of seconds. So it's pretty ubiquitous. But whenever you ask somebody about Selenium, they say, what do you feel about it? You love it? Is it the greatest thing in the world? And they say, yes, I love it, but it has challenges. And so what are those challenges? And so we saw in this same survey that it broke down to building tests that were maintainable over time. Tests that were able to continue working even though the application was changing. Understanding which locators to use in the test, getting it to run in different operating systems and devices. Now, a lot of that is handled by ApplyTools, but when we take those top few bullets, it really is an issue of maintenance. And then some creation. There's a lot of tools that are out there for creation, but building tests that are maintainable from the beginning is the #1 challenge. And so that's what we want to show you today. We want to show you how we can solve these issues of maintaining tests when the UI changes, when the application's weight conditions are insufficient, how to build the right locators, the minimal set of locators required to drive the browser, and then also show you how you can get some good debugging, diagnosing information, and reduce the overall time to execution. And we do that through Parasoft Selenium. So Parasoft Selenium is your AI-powered bot that will help you with your existing Selenium tests. It's not a proprietary testing system. It plugs into your existing Selenium test practice to eliminate your failures in your tests by 50%. By monitoring the execution and watching as the tests are about to fail, we can provide AI-powered recommendations into your CI pipeline to help you not only understand how to fix those tests, but in cases, self-heal them. And what that will do is reduce the overall time that you spend maintaining tests, Daniel mentioned, twice as long as creation by up to 80%. And I'm going to show you how we can reduce that time from hours to minutes. And at the very end, after we see some really amazing stuff in the ApplyTools platform, I'll circle back and show you how we can create these great tests from the very beginning. So I'm going to go ahead and show you a demonstration of how this works. And I'm going to start by running an existing test that I have inside of my IDE. Now, today I'm showing Eclipse, but we integrate into IntelliJ. I'm going to be showing you a JUnit 5 test, but again, the TestNG frameworks are also supported. So here I have a test that I've created here inside of Selenium, inside of Eclipse. I'm really proud of this test because it covers some really important functionality in my application. I'm also proud because I've used an industry best practice called the page object model. In the page object model, you define the pages for your application as reusable objects. You can then define the element locators on those pages. And if one were to ever change, you just change it in the one spot and it propagates through the rest of the test. So this is a highly maintainable way to make tests. for that reason, I do really like this test, and it makes me really frustrated when this test breaks due to application change. And so I'm going to show you a demonstration of that today. But before any of that happens, I want to go ahead and just execute the test and show you exactly what it's doing. So today I'm going to be testing this banking application, Parabank, and I'm going to be doing 3 different tests. I'm going to test my accounts. I'm going to test this bill pay page here. Okay, great. And now I'm going to test my request loan page. Okay, so all of my tests that I created execute against my application. That's great. But development has just told me that a new version of the application is going to be available. And so what I'd like to do is I'd like to take those tests and run them against my new UI. And so what I'm doing is I'm simply changing the endpoint from version 1 to version 2 just to run a sanity check. I'm also going to activate Parasoft Selenium. So Selenium, as you can see, comes as a plugin to Eclipse and IntelliJ, and also is something that you can run from the command line with a series of arguments. And what it does is it monitors the execution of your existing Selenium tests. And it looks to see if anything breaks due to a bad locator, bad weight condition, stale element reference, etc. And if it does, it's going to tell us what happened and how to fix it. So let's go ahead and execute that. So I'm running those same tests that I just created against version 2 of my application. Okay, it looks like the first test was successful. Hopefully there's nothing wrong. Spoiler alert, there's something wrong, and here it is right here. There's something wrong with this page, and I'm not exactly sure what it is because it looks identical to what it looked like before, but the test seems to have stalled, well, and it broke. Okay, we'll talk about that in a second. Here comes test 3. Wow, this page looks really different. It looks like I've got some dynamic loading content in there. Let's see if my Selenium test can, okay. So it looks like the application has changed and has broken 2 of my test cases. But no worries, because Parasoft Selenium was watching. So here's the Parasoft Selenium analyzer report. And what it's saying is, yeah, you ran 3 tests. 1 of those tests passed, 2 of those tests failed. And it failed because of a bad locator or weight condition and then something else that it wants to talk to us about. Now, here's the report, and it says that the first test failed because it couldn't click on this payee phone number. It provides us a screenshot so that we know where it was in the test when that happened. But it also provides us with recommendations. And this is where we can see Selenium's AI at work. So what it's telling us is that it couldn't click on this element locator because it changed. Now I've included something down here at the bottom to explain how it changed. It turned into a dynamic locator. You see a lot of this in things like Salesforce and Guidewire, where the page is completely dynamically constructed. And as such, this payee phone number is no longer going to work in the new version. But no worries, Selenium came back to us and said, hey, if you use this locator, or any of these top 5 or 6 locators, you're going to have varying degrees from 96 to 89% probability of success in clicking on that. And that's a combination of stability, which says Selenium has been watching the application runs over time and says, hey, this is the right element locator to use, as well as weight, which is something I can customize for my organization because maybe I like CSS locators over XPath locators. Nevertheless, I have a new locator that it's recommending to me. And I also get some test details and a stack trace so I can feel good in applying that to my code. I've got something else here that failed. It was having trouble clicking on this. And as a human, we can say, well, it's because the button wasn't ready yet. And Parasoft Selenium is recommending that we turn on self-healing in order to resolve this issue. So we know what's going on with the application. We know what we need to fix. How do we fix that? Well, back here in the IDE, those recommendations were delivered right here into my view. And I get the same information that I got before, but I also have the ability to jump right to the line of code in my test and make the update right here to that new element locator. And this significantly reduces the maintenance because I know now that this is the actual line that was being affected. But wouldn't it be cool if we were able to actually self-heal that test at runtime? See, in order for this to happen, the test had to fail. And so what I'd like to do is to tell Selenium to automatically apply that, that recommendation at runtime. And I also want to push the information to amplitude. So I'm going to show two things at once here. I'm going to show Selenium self-healing, which is as simple as just telling it to self-heal. And I'm also going to tell it to push data to amplitude. In order to integrate with amplitude, I don't have to actually change anything about my test. I can just tell Parasoft Selenium, hey, push that data to this instance with this demo, with this application name, and then I just supply it my API key over here. And then once all that information's done, I can simply run the test, and not only is it going to perform self-healing, it's also going to push anytime there's a navigation or a click, it's going to push that information to amplitude. So we can immediately take advantage of all that powerful AI inside of the amplitude ecosystem. Now, this is just going to take a second because it is taking a screenshot every single time that I'm navigating. And I want to take this time to point out one other thing you're going to see in the test, and that is performance benchmarking. One more additional secret feature that I turned on was I wanted it to report when execution time exceeds a specific threshold. And this will help me understand if my performance timings are starting to get out of whack. Okay, now this particular test that we're about to look at is going to be interesting because we're going to see a combination of the AI self-healing and the screenshot. So remember right here, we have a broken test. Now look in the bottom right-hand corner. Parasoft Selenium said, oh, there's a problem there. I'm going to self-heal that. I went ahead and chose a new locator and the test proceeded. And what you're going to see is that not only did we self-heal that locator, but Amplitude's visual AI is going to find out that there's something else wrong with that UI that none of us are actually seeing right now. All right, so here comes the third test. And in this case, it's that dynamic screen that has that loading content. And you'll see the same thing happen here. It's not able to click on from account because the element isn't ready. Selenium's going to pick up on that and say, okay, you know what? I'm going to wait just a little bit longer, self-heal, and then allow you to click that button. Okay, so now all of my tests executed. Let's go ahead and take a look at the Selenium report. And it's going to take just a second to come onto the screen. But the cool part is that we're actually going to see a combination of Parasoft AI and Amplitude's AI at the same time. So here's our new report, quite a bit more colorful. It tells us 2 tests passed, 1 test was healed. Here's the breakdown of the issues. Now we already know here what this guy is, the bill pay. This time it looks a little different because it says, hey, I used AI to heal this one. But what's also interesting about this is you'll notice that Amplitude is actually indicating visual changes on my pages. And we'll get to that in just a second. In addition to those visual changes, I'm also getting some warnings about performance thresholds being exceeded. So in this case, my tests, even the one that was self-healed, is exceeding the average. Maybe it's time to think about running a performance test on those. Okay, let's round this out. This test was healed, but Amplitude indicates visual changes. Let's dive into the Amplitude's dashboard. And you'll see you can jump right from the report. We'll jump into their dashboard. Just take a second here. So here we are in Amplitude, and we're going to have Iran talk us through a lot of the advanced capability in here. But what's really powerful about what just happened was that information was sent up. We see that, okay, there are unresolved differences between our baseline and this test execution. And if I dive into this one, this is the test that just fired off. This is the one that just self-healed, phone number. But look, there's something different on the page. I'm going to use Amplitude here to reduce the number of displacements on the page, And if you look a little closer here, look at this, guys. We have a brand new field that was never in the test to begin with. And Applitools picked up on that and said, hey, you know what? There's a pretty big change. I have an untested element. And so not only did we get the self-healing, but we also got the ability to understand assertions that we never put into our test. And so with that, that is the power of Selenium. What I'd like to do is now pass it over to Aaron to talk us through some of the advanced visual testing capabilities of Applitools. So over to you, Aaron.
Thank you, Chris. Let me share my screen here. Yep. So just to go over and connect all the dots that we've seen here between what Daniel was talking about, the AI capabilities of Applitools in the world of visual testing, and what Chris was showing with Parasoft and this headache of managing those locators. This is a huge pain for everyone. And the combination of these two tools of not needing to maintain your selectors because they break frequently by using Parasoft, and reducing the number of assertions that you need to add to your code because they break as well by using Applitools, you can actually get to 100% coverage and very high stability of your test while running it. So this means that your QA team can actually focus on testing and less on stabilizing their test environment and maintaining it functionally wise. So I see questions pouring in through our Q&A, and that's wonderful. So keep putting them in there. And I see many of them are talking about our AI capabilities and what it can handle and what it cannot handle. So let's jump straight into that, and then we'll go into other advanced features within Applitools. So let's look at this example. So I'm going to zoom in here and show you a screenshot that we grabbed on IE of Paycheck's website. And this customer wanted to find out whether their page is broken. Now, broken can be a philosophical discussion. What's the definition of broken? But the AI has very dynamic capabilities into understanding what's broken and what's not. So let's put these two screenshots side by side. And on the left, we see the baseline, which is what is also referred to as the expected result. And on the right, we see the checkpoint, and that's the current test that we just ran. And if you noticed, we're trying to compare IE to Chrome. So normally I don't recommend comparing apples to oranges, but this is just to emphasize how flexible the AI engine is. Those two are so different because of how those browsers render screenshots. I mean, rendering screenshots by definition is affected by the machine you're running on, the display driver you're using, the display card you're using, the OS version, the browser version, and so on and so on. So getting a stable test is very challenging, and for visual testing, I mean. And here we can see that we're able to actually find some mismatches between those two very different screenshots. Now, when I say very different, if you look at it, you don't notice immediately what's going on. But I'm going to put them one on top of the other, and I'm going to toggle back and forth. And when I toggle back and forth, you easily notice that the font is rendered differently. Some of the menu items are shifting around, jumping, the text width, and so on and so on. So this is causing a lot of noise in the system. And when you're using a tool that does pixel-to-pixel algorithm comparison, this noise is translated to false positives. So exact is an algorithm that we have here, which is literally pixel-to-pixel. And you can see everything is highlighted in pink. And that's because every pixel in this image is different. So then, you don't want to deal with the threshold or fuzz factor or whatever those free, open source, and even paid commercial tools who claim to do visual testing offer. And you don't want to deal with that because that's additional maintenance on top of everything you have. So a lot of our customers come to us after they share this pain and realize that this just adds more work to their daily tasks rather than help them save time. So let's talk about the AI algorithms here. So the first AI algorithm is called strict. Strict emulates the human eye and brain and will only point out things that are visible or important to the human eye. And we can see that some of the elements that are pretty, visible here are highlighted. But if you look at the logo, it's not highlighted, and this lady is no longer highlighted. And even though she's jumping right and left, you see I'm toggling back and forth, it's still flagged as a match. But this is not good enough for our customer. They wanted to find out if anything is broken on the page. And for that, we have another algorithm that is called layout. Layout can handle dynamic content. So this means that if there's different words, different images, different values in dates and time, for example, and so on, you will the AI engine will mark this as a pass. So let's render it with layout. And these are just preview modes. Obviously, all these flags can be set from your test suite. And we see that now nothing is highlighted except for one thing that's at the bottom right. So I'm going to navigate using my radar to that element. I'm going to remove the highlights. And I can see that it's pointing out to this area. So I'm going to put them side by side. And I can see that now this image is missing from that button. So this, by using the right combination of algorithms, we're able to clean the noise in the test and focus on what's really broken. And this ties to what Dan was talking about, functional testing using visual testing tools. And here's an example of a functional issue that's caused by a visual defect. Now, why is it a visual defect? Because this image might be actually in this white gap. And if it's white over white, your functional test will most likely pass because your Selenium test will be able to click on that image, which is wrapped with a URL, and will be able to log in or check out or add to cart or perform whatever action you have on this page. So your functional tests will pass. This will end up in production, but then you'll see a drop in sales for that specific page, or no one is logging on to your application for a month now. And you're looking at, the first thing you do is you go to the test results and you see everything is passed. So this leads to a very important point here to emphasize that visual testing is actually replacing or adding a lot of value to functional testing. We see a lot of our customers that are actually dropping the asserts, which are a headache to manage, and replacing them with a visual validation. Now, with another disadvantage of functional testing with the traditional way is that you're only focused on what may or what you think might break. And that doesn't give you 100% coverage. But when I show this full page screenshot to the AI and I ask the machine, tell me what's the difference here, I will get 100% coverage. So this is one example. Here's another example of validating dynamic content. So here we have this customer is testing their mobile app, okay, because we can run both mobile and web. And this is dynamic content. So every time we're going to visit this page, we're going to get different values. So for that, we're also allowing our users to add regions for specific areas in the application, saying, this area, I want the AI to process it with layout because this has dynamic content. So I don't care about the value of the stock here, but I do want to make sure there is a number here. This is not ignore, okay? Other tools that do pixel to pixel are ignoring regions. And by ignoring regions, you don't know if this didn't appear or it did. So you won't get alerts for missing elements, but with layout, you are getting those alerts. And let's keep on adding those regions. And again, this is something you probably want to do in your code. And here we see that this contains dynamic content. And if one of them is still highlighted, it's probably because it's broken. And here, by using the right combination of algorithms on the page, I was able to find this bug where text is not appearing on a block. But if I was looking at it at the beginning, it was all highlighted. And again, a lot of noise, and I'm not able to zoom in and find out the issue. Once I found some issue here, I can highlight it with the bug region and report to R&D, missing text on span, And obviously, if this is configured with my Jira account, I can plug this directly into Jira. Now, when I'm testing my application, I have various hats I'm wearing. Product, for example, is using applitools for, let's say, localization testing. And I saw this question earlier in the Q&A. So in terms of localization, here's an example of a login page that's in 2 different languages, French and Spanish. And we can see that the AI is marking it as match. And that's because we are using the layout algorithm. If I was to use strict, obviously this thing would light up like a Christmas tree because everything is different on this page, content-wise. But if we're checking structure, layout is the algorithm, is the go-to algorithm. And just to show you how cool it is, once it's done rendering, if I zoom in here, I can see that those 2 images are of different heights. And this is very critical to understand, that the AI brain is flexible enough to understand that things shift around and the height of the images can be different, but structurally they're intact. And this is caused because certain languages are rendering different paragraphs in different lengths. So this one has, for example, 3 lines, and this one has 2 lines. But because all the elements under it are shifted accordingly, this is flagged as a match. If those elements are not shifted or not pushed down based on this, the height of this paragraph, then you most likely would have an overlap of 2 elements, and the AI would highlight that as a mismatch. Now, developers also love us because once they get to, you know, they open a Jira card that the QA team reported, they can quickly navigate to that test results and easily see what's going on. So here we see that someone accidentally pushed an older version of this page because it was 2020 and now it's 2019. And we offer those developers the ability to save a lot of time, because at this point, this developer needs to pause whatever they're doing, go back to the branch that was, you know, that was being tested here, that was probably released 2 weeks ago, reproduce this environment and try to reproduce this bug on their machine or in their environment, and then reverse engineer it and find out what's going on. That's a lot of steps and takes a lot of time. But here, by using our root cause analysis feature, we're giving them the ability to simply click on the element, and we show them which element in their code is misbehaving and what has changed. So in this example, it's a text change, but sometimes it can be an attribute added or removed to an element. And now they can go back to their code and find out exactly which line of code in their pull request was touching this specific element, and save them hours and hours of debugging to find out what's going on. Another example here, let me zoom out a bit, is another favorite feature for marketing team, for example. They're doing a lot of I would say, landing pages tests. So by being able to add different variations of the baseline, they're able to save time for QA because there's no need to rewrite a test to accommodate the new variation of the page. So for example, in this test, you see here the women leaders image is flipped around from this text. But so there are 2 options or 2 variations for that page. So we can simply create a new variation, and then we end up with both of them. And the AI is smart enough to find out which one is the closest, and then point out to the actual bug at the bottom, which was 2019. So again, the combination of many tools here that are AI driven saves a lot of time. The last thing I want to show you before we open up the floor for Q&A is the ultra-fast grid. The ultra-fast grid, like Daniel was mentioning, gives you the ability to take a screenshot once and run it across various devices and browsers. So when I say various devices and browsers, for example, we can pick up different browser and different browser versions. We can pick different devices, different operating systems, different resolutions even. Here we can see different resolutions. And this, in this example, I just grabbed a single screenshot, okay, of a homepage of Slack in this example, and I rendered it across all devices. And this means that I now can, you see, this is, for example, on a BlackBerry. Okay, there's iPhone, there's pretty much every device there. And it's called the ultra-fast grid because I grabbed about 40 different screenshots, but sorry, technically I grabbed one screenshot, I rendered it against 43 different browsers and devices, and it took 20 seconds. And this is normally the time it takes, you know, any other vendor in the market that is offering cross-browser testing just to spin up one VM and run a single test. So as opposed to other vendors that offer cross-browser testing, you do not run your test on Safari, on IE, on Edge, on Chrome, on Firefox. You do not run your test 5 times. By running it 5 times, it increases the odds of, you know, flakiness and things breaking and you being frustrated of, you know, with, you know, the stability of your test. And then you need to rerun it again. By running it once on, for example, Chrome, we're grabbing the DOM behind the scenes and rendering it on our grid. And that's something Daniel was talking about earlier. So grabbing all the DOM assets into one bundle, uploading it to the visual grid, and then spinning up those Docker containers. That's how we're way faster than the VM kind of approach products. It's way faster how we're spinning it up. We're only rendering it. We're not running your test on all these browsers. And then we're taking the screenshots into your eyes dashboard and they end up here. So this is a huge time saver for everyone. And speaking of 100% coverage, this is how you can get there, by literally running a visual test and then multiplying that across all the other browsers and devices. Now, at some point, you're going to end up with all these screenshots in your dashboard, and it's going to be overwhelming because let's look at this example. Let's pretend I work for GitHub and I just ran this test and I have about 80 different steps here and all of them are a mismatch. So this can be a lot of work for me to go manually over each and every one of them and accepting or rejecting them. And if I'm going to look at this issue here, I can see that the logo, someone played with CSS and changed the logo from black to green. So I'm going to give product a call and ask them, was that intentional? Or I can go ahead and reject all these tests. And they're telling me we're going through some rebranding. Okay, good to know. I'm obviously the last one to know that. Now I need to go and accept all of these. And knowing myself, I'm a lazy tester. I'll probably go through a handful of them, look at them, make sure, yeah, that's fine. All of them look the same. You know, it's always highlighted in top left, the pink area. So no point in me going through all of them. So I'll probably select all and then accept, which will make all these my future baselines. This is probably a mistake because what this means, I could introduce bugs into my baseline. And this is another example where the AI kicks in and helps us even further, and not only through the, during the test, by enabling us to group all these tests by similar differences. So the AI now is crawling through each and every screenshot and looking at those differences that are found in each and every one of them. And I'll show you later, this is done across different resolutions, different browsers, different devices, and so on, and grouping them based on those similar differences that are found during the test. So let me zoom out here. Obviously, we have some demo trolls here. So we see 2 piles. One of them has 40 steps and the other one 36. Let me just refresh that. He decided to misbehave. Now, before I group it again, just to show you here, different resolutions, different OSs, different browsers, and even different operating systems, right? I mean, some of them are Android, some of them are on Windows 7, for example. Let's try grouping again. And now it worked, and we see we have 2 piles. So one pile has 36 steps, and the other one has 40. So navigating to the pile with 36, we can quickly see that all of them share just one issue, and that's the logo change. So I can safely accept these and make them my future baseline for next test. However, I have another pile with 40 steps, so I'm going to navigate in it, and I'm gonna see quickly, okay, there's only one mismatch. And when I zoom in, I can clearly see that this is a huge mistake and this logo didn't render. So I can go ahead and reject it and report back to R&D saying this file wasn't rendered correctly. Go back to your CSS update and make sure it's also rendered correctly for these tests. This covers the visual testing part. Chris, back to you.
Wonderful. So yeah, a lot of toys in that bag. So let me
absolutely
let me share my screen and we'll round this guy out. So basically where we left off with this was that I'd created my Selenium test, I'd ran it, I got the AI powered self-healing, sent it up to Applitools, able to then really finely drill in with that right algorithm and then run it in the grid, all of that really powerful stuff. So where I want to finish is how do I solve this problem, right, of having this email field? I need to create a new test. And so this is the last thing that we'll show today, and we'll jump into questions. So Parasoft Selenium does supply a recorder that allows you to record UI actions, as well as some API tests. That's the subject for another webinar. What I'm gonna do is I'm just gonna create my tests here against my application. I'll just log in. And so you would either do this at the beginning or you would do this as you were updating your tests. So we'll just say, we'll just pay this off to Applitools. None of the rest of this information actually matters for the purpose of what I'm trying to do. This time we'll add an email. Okay, put an account. Another piece here. Verify account, and then the amount will be $100 or $1,000. Okay, now we'll go ahead and stop the recording, and we'll call this Parasoft Parabank Bill Pay. We can then supply a description, maybe add a requirement so that we can create that nice integration with our build system. Download the recording. That's going to go ahead and give me a file that I didn't click on that I can go ahead and use here inside of my IDE. I'm not going to get really deep into this, but I have the ability to either update an existing test, thus updating the page objects or adding new page objects. Or if I'm brand new and I have no tests, I can just create a new Selenium project, supply it with my my file. We'll just use this one for now. Parabank. This will create the test either in JUnit 5 or test ng. Test bill pay. Finish. And you'll see here, I get a brand new Selenium project that can easily be Mavenized, that has the actual test class and all of the page objects. And that takes us right back to where we started, because now I can run this test, I can take advantage of self-healing and everything else, and get those that information up into Applitools. So this is what the workflow looks like end to end. You start by leveraging manual testing activities to create your pure Selenium scripts. No vendor lock here. You could walk away with great Selenium tests. They're built using the page object, so you can update them at any time, thus updating the page objects and test scripts. You then execute those either as a part of your CI pipeline, because it is just a Selenium test. You could run that easily from a Jenkins or from the command line. But you push the results up into Applitools, thus taking care of all of your validation. If you have any tests that have broken locators or bad weight conditions or stale element references, with what things I like to call test automation failures, Parasoft Selenium will automatically retry or self-heal those at runtime, and then provide those recommendations back into your IDE so you can fix those tests. And all of those results can then be pushed into your bug tracking system so you can really understand and take advantage of that coverage and link it to your requirements over time. So pretty powerful stuff. We are better together, Parasoft and Applitools. So If you want to go ahead and get started, here are the links for the different solutions. You can get a free trial of either of them. And I think, guys, this is a great spot for us to go ahead and start digging into some questions. So I know there was a lot for everybody to see here. I'm going to go ahead and just dig in here. And I've got one here, Aaron, that you, I think, might be able to answer. It says, how about navigating items, click, drag inside of a canvas? Is that something you can answer? So
we are not the test driver. Parasoft is the test driver in this story here. So as long as you can grab a screenshot with whatever tool you're using to drive it, we can validate it. We do have an experimental tool that's in beta now, so I would recommend reaching out to me after that webinar, and maybe we can get you on that beta plan where you can actually click on elements that don't have selectors, like in the case of Canvas, for example. We get that a lot from gaming companies where you have a mobile app that is literally drawing all the elements on the screen and needs to be managed or driven and then validated. So good question. It's an edge case. This is why we have it in beta, but we do see the demand for that increasing. So please reach out to me afterwards.
Great. So here's one for the Parasoft side. How does Selenium calculate confidence factors? So really great question. Selenium is taking a look at those DOMs. So as those tests are executing, it's taking a look at the DOMs, and it calculates the confidence factor by traversing the current DOM, taking a look at what it was unable to click on, and then using some intelligence to go back in time and say, what could I construct that would not only click on the element now, but would be successful over time? Because we want to be able to cover you in all the different versions. And so one of your factors is that stability. And that stability says, hey, I was 100% of the time with this new AI-powered locator able to find the element. Or maybe I wasn't 100% of the time. And so that's factor one. Factor two is locators have weights. Different organizations like things like TextLink, CSS, maybe XPath might even be the right thing to do. And those weights, those locator weights factor into the confidence. And so if you get a high confidence locator that you have chosen and it's highly stability, you'll have a higher confidence. Okay, what else do we have here? Here's one for you guys. What's the difference between visual AI and snapshot testing?
Yeah, great question. So snapshot testing basically is grabbing, and again, it depends on, there are different definitions. It can be literally grabbing two screenshots, or some of them grab the DOM as well. Comparing two DOM trees is a nightmare, and there are tools out there that claim to do that, but DOM doesn't always necessarily mean that it was rendered the way that the designer planned it. So grabbing a screenshot and doing visual testing on it, this is what I'm going to refer to in this answer. Using a snapshot, you literally take screenshot, and all the frameworks out there do that, regardless of framework and language. But all of them are based on the same pixel-to-pixel algorithm, which is very good if you want to only compare a very tiny component on your website that's stable and doesn't have dynamic content. But in reality, we want to cover more than just testing our logo, or if we're looking at the screen in front of us, let's say I want to check this robot right here. So yes, if I grab just this robot in Parasoft image here, then most likely the pixel-to-pixel will pass. But if I want to test, and let's say the Amplitude's login page right here, all the elements on the left are probably randomly appearing based on some random factor that we have. So in a pixel-to-pixel algorithm, you'll most likely need to ignore that region, or at some point just stop testing it, because it will fail it every time, because you can't put a threshold on that. And the AI engine, like I showed, we have various algorithms, can help you figure out which element or what's wrong with the page. And based on what your expected result is, this is how you pick the algorithm for the task. So if you're looking for a typo, you would use strict. If you're using for structure issues like new elements or missing elements, you would go with layout.
That's great. I just have one thing to add to that. This is Dan. Just on the difference between these tools, we find that for full application testing, using like that snapshot or pixel-based approach could appear to work like at first, right? When you have minimal changes to your application. But over time, your application changes and changes and changes, and technologies change, browsers change, how things are rendered change, right? And this starts to create an overwhelming amount of false positives. We found that somewhere in the ballpark of 30% of all snapshots. So if you're talking 25,000 snapshots per month, that could be 7,500 false positives that you get per month. And if you triage those at somewhere in the ballpark of 90 seconds per screen, you're talking 180 hours of triage time. So it really makes pixel by pixel or snapshot testing ineffective in the long run. Short run, okay. Very small snippets of your website, okay. Full app testing, it's not going to do the trick. You really need AI in those situations. And Applitools is the only provider of visual AI.
Good stuff. All right, so we've got about 4 minutes left here. I want to lump some of these questions together. I'm seeing a lot of questions about CI pipelines. So I'll go ahead and I'll start here and then I'll hand it over to you guys. So everything that you see from an execution perspective is designed to actually run from the CI pipeline. However, you're normally running your Selenium JUnit or TestNG or whatever tests you're executing, say maybe as a build step in Jenkins, which is say a post commit to your code check-in. This, from a Selenium perspective, you're simply calling a jar file, and that jar file then instruments the execution of the Selenium test between the browser and WebDriver. So it's very CI friendly. It doesn't need to be plugged into some home base or something. It's contained, and then the information is sent from the Selenium execution to Applitools. And from an Applitools perspective, it's CI or with or without Selenium. So at least from our side, you can easily drive that from any of the common build systems or from a straight homegrown command line execution. Do you guys want to add anything to that?
No, just one small thing here. For us, it's transparent where we run, right? We're not a tool that you need to install anywhere or run anywhere. We exist in your test code. So if your test code runs in a CI, we're going to run in it. If your test code runs locally, we're going to run in it. So it's transparent to us.
Excellent. Couple of questions I just want to knock down real fast. Does it have the capability to integrate with existing Cucumber framework? Absolutely. If your underlying Selenium code is a Java-based TestNG or a JUnit, we run exactly the same way as if you're a pure page object created or inline test. And then here's another one for, can Chris share an example of the code earlier? Actually, that code, that was created with my recorder. So I recommend downloading our 2 trials and create that code. You'll get the page object and everything you need to execute. What do we got? 11:59. All right, so let's look for a good one here, unless there's one you guys want to particularly answer. How about, I actually saw one earlier. Oh, this is a good one. When a test case passes with self-healing, Applitools showed an additional field. How will testers know when to look at the Applitool result, whether it has changed or not? Excellent question. So when we send the results back from our execution to our centralized dashboard, we mark self-healed tests or any tests that have a visual change as incomplete. They're not failed, they're not passed, they're incomplete, needs review. And then when you go and you look at those results, you'll have that incomplete bucket that will then be split into self-healed and visual changes and potentially performance benchmarking changes. And that's the place that you go to say, okay, if it's failed, there's something wrong. It's an automation, an assertion fired, something is not right. If it is incomplete, then that's when I know that I need to either take the action to go and look in applet tools to get the information as to what happened, or potentially take the recommendation from Selenium and update my code. So it makes it really, really easy to separate those three. All right, guys, there's still a ton of questions, but we're at time. So let's go ahead and call it. Thank you guys so much. I think this was a really interesting and exciting topic. And any of these other questions, we're going to go ahead and answer directly in email. To everybody out there, stay safe and enjoy the rest of your week. Thank you, guys.